So we come to the million-dollar question. What is logistic regression? Linear regression is a continuous response modeled as a linear combination of the features. Logistic regression, on the other hand, is the log odds of a categorical response being true and is modeled as a linear combination of the features. So instead of writing y equal to beta 0 plus beta 1 x as in case of linear regression, we write the log of odds, and odds, as we already know, is just probability divided by 1 minus probability. So we take the log of p by 1 minus p to be equal to beta 0 plus beta 1 x. This is called the logit function, and this is the function that we are trying to come up with when we are trying to do logistic regression. Now, sometimes symbolically, the p is also denoted as pi. So we can rewrite our equation as log of pi by 1 minus pi to be equal to beta 0 plus beta 1x. Now, I've skipped a bunch of steps where I can show you how this equation transforms into that. But if you just do the math simply on your head, you should be able to get this. So what do I have to do to come up with pi by 1 minus pi on the left hand side? I will have to take the exponential of the left hand side and the right hand side. Hence, in the next step, we see a term like e to the power beta 0 plus beta 1 x. And then if we just do a series of simplifications, we'll end up with the probability or the pi to be equal to e to the power beta 0 plus beta 1 x divided by 1 plus e to the power beta 0 plus beta 1 x. So in other words, logistic regression outputs the probabilities of a specific class. Those probabilities can be converted into class predictions. So go back to the rain example. If the probability of raining is 0.9, then there's a high chance it will rain and you should take your umbrella out while you go out to work. If it is 0.1, it's a very low probability and you might want to skip taking your umbrella. So it is these probabilities that give us the confidence to take a decision. And hence, I'll just repeat those 2 points. Logistic regression outputs the probabilities of a specific class. So in short, it outputs the confidence with which we can take a decision, but ultimately the decision is something that we as humans have to take by setting the probability threshold. We can make a statement like, if the probability of raining is greater than 0.7, I will take an umbrella, otherwise I'll just skip it. So logistic regression outputs probabilities, and those probabilities are something that will help us generate the class predictions. Now this logistic function has some nice properties. You might have seen above that it takes an S shape, and we'll just redraw that below, but I'll just come back. The output of logistic regression is bounded by 0 and 1, which is exactly what we want. Ultimately, we are doing class predictions, which are either on this side or on that side. So we have covered how this works for binary classification problems. Binary classification problems means classes which have only 2 kinds of responses. So we came up with a variable called household, which had 2 values, 1 and 0. But what about multi-class classification problems? That is something that have more than 2 response classes. Now the most common solution for classification model is one versus all, which also goes by the name of one versus rest. Decompose the problem into multiple binary classification problem, but multinomial logistic regression is something that can solve this as a single problem.